Okay, here we are. This is Unit 10, Lesson 3. This is areas of regular hexagons. Once again, let me remind you that if you have any questions, write them down while you're going through the video because you can always pause the video and write your question down, bring it to class, and I'll be more than glad to discuss it with you in the class before we actually start any work. Okay, alright, so the areas of regular hexagons, we have a few little details to get taken care of before we start. Here's what we got. For definitions and things, first thing you got to do is think about the size of the interior angles of a regular hexagon. So what you do is you take 180 times the number of sides minus 2, which is what gives us the total of the interior angles. And since we have a total of 6 angles this time, we divide by 6, gives us that each angle here has to be 120 degrees. Okay, so when we draw this, this shows the center, the radius, and the apothem and the relevant angles. So here's what you got. If you notice that you got the radius running from it's half of a diagonal, which is coming from the center to the vertex. The apothem is coming from the center to the midpoint of the side that it's going to. And then x represents the length of half of one of those sides. So this means that 2x represents the length of the whole side. Okay? Alright, so with that in mind, here's what we have. We have that in the following examples that we want to find the areas of the regular hexagons using the apothem formula, which says that the area is equal to 1/2 of the perimeter times the apothem. Okay, example 1. Find the area of this hexagon. Okay, so here's what we have. We have a hexagon. The only thing they gave us was that the apothem is 5 square root of 2. Once again, since the original angle started out at 120, since this is also an angle bisector, that's the radius here, that means that the angle inside the triangle here is 60, and the length of half of the side is going to be equal to x. So we can find that by using the tangent. So the tangent of 60 is equal to the opposite leg, which is 5 square root of 2, over the adjacent leg, which is x. Okay, so we cross multiply. That gives us x tangent 60 equals 5 square root of 2. To solve for x, we divide both sides by the tangent of 60, so x is equal to approximately 4.08. Okay, so that's half of this, so we're going to go ahead and find the length of the side, which is going to be 2 of those, so 2x equals 2 times 4.08, which is 8.16. So each side of this hexagon is approximately 8.16 units. So I believe we're ready to find the area now because we can get the perimeter and we know what the apothem is. So we go ahead and put it into our formula. So that's 1/2 of 6, because this is a hexagon, times 8.16 times 5 square root of 2, which gives us that the area is approximately 173.10 square units. Since they didn't give us any dimensions, we don't have anything to square at this point. Okay, let's move on to example 2. They want us to find the area of this hexagon. Okay, this time they gave us the length of the side, which means that this half side down here is going to be equal to 12. So that will let us figure out what our apothem is, and that's the other part we need to find this. So tangent of 60 is going to equal to the opposite leg, which is the apothem, over the adjacent leg, which is 12. So 12 tangent 60 is going to equal the length of the apothem. So 20.78 is approximately equal to the length of the apothem. Okay, so now we can go find our area. The area is equal to 1/2 of the perimeter times the apothem. So the area is equal to 1/2 of 6, because once again it's a hexagon, times 24 times 20.78, which gives us approximately 1,496.16 square centimeters. Notice that they did give us dimensions here, so we need to carry it forward into the answer. Okay, let's look at example 3. They want to find the area of this hexagon. Okay, this is one. They gave us the length of a radius, which is 3. Okay, once again we have the 60 degrees here, and this is going to be half of the side is going to be x, and the apothem is going to be this part right here. So what we can do is we can find the length of the apothem by using the sine, because the sine of the opposite leg over the hypotenuse is what we have here. So this gives us the sine of 60 is equal to the apothem over 3. Cross multiply gives us 3 times the sine of 60 is equal to the apothem. So that gives us approximately 2.60 equals the apothem. Okay, the other thing we need to find is we need to find this part right here so that we can multiply that by 2 and then multiply that by 6 to get the perimeter. So we're going to use the cosine for that, because this is x is the adjacent leg of the 60-degree angle and 3 is the hypotenuse of that triangle. So the cosine of 60 is equal to x over 3. Cross multiply gives us 3 cosine 60 is equal to x. So 1.50 is equal to x. Okay, so the length of a side is going to be 2x, which is going to be 2 times 1.50, which equals 3. Okay, so we're ready to find it now. With the apothem is equal to 1/2 of the perimeter times the apothem length, or the area is equal to 1/2 the perimeter times the apothem length. So let's fill it in. The area is equal to 1/2 of 6 times 3 times 2.60, which gives us approximately 23.40 square units. Okay, let's move on to example 4. Find the area of a hexagon whose perimeter is 36 feet. So this time they gave us the whole perimeter. So we divide that by 6, gives us that each side of the hexagon is equal to 6. So half of that is going to be equal to 3 next to the 60-degree angle. Okay, so we're going to need to find the apothem before we're ready to go to find the area. So this time we can use the tangent to find the apothem, because we have the adjacent leg and we're looking for the opposite leg. So the tangent of 60 is equal to the opposite leg, which is the apothem, divided by 3. Cross multiply gives us 3 times the tangent of 60 is equal to the length of the apothem. So that gives us 5.20 is approximately the length of the apothem. Okay, so we're ready to find the area. So the area is equal to 1/2 of the perimeter times the apothem. So in this case, since they gave us the perimeter was 36, the area is equal to 1/2 of 36 times 5.20, which gives us that the area of this particular hexagon is approximately 93.60 square feet. Once again, they gave us a dimension in the beginning, so we need to finish with a dimension in our answer. Okay, let's go to example 5. Okay, they want to find the area of this hexagon. Okay, this hexagon, they notice what they did here. They gave us coordinates of the 2 vertices. Okay, so this means we have to find the length of this by using the distance formula. Then whatever that is, take half of that, and that will be the length of this side of the triangle, and we'll have to find the apothem. Okay, so the distance formula tells us that x is equal to the square root of the quantity 6 minus 4 squared plus the quantity 7 minus the square root of 3, which is this one right here, minus 7, and all that together is squared. Okay, notice that what's happening here is we got a 7 subtracting the square root of 3, and we got a 7 over here. So 7 minus 7 is equal to 0, which leaves us with just the negative square root of 3. Okay, so when we square these, then what we get is we get 2 squared gives us 4, square root of 3 squared gives us 3, so 4 plus 3 is going to equal 7, so we're left with x, which is the length of the side here, is equal to the square root of 7. Okay, so this means that this little piece down here is this right here divided by 2, which is the square root of 7 divided by 2. So to find the apothem, we take the tangent of 60, because we're looking for the opposite side, and it's divided by the adjacent side that we already know, which is the square root of 7 over 2. So the tangent of 60 is equal to this. We're going to cross multiply, so the square root of 7 over 2 times the tangent of 60 equals the apothem. So when we calculate this out, we get approximately 2.29 is equal to the apothem. Okay, now that we know the length of the side and we know the apothem, we're ready to find the area. So the area is equal to 1/2 of the perimeter times the apothem. So the area is equal to 1/2 of 6 times the square root of 7 times 2.29, which when we calculate that out, we get approximately 18.18. There were no units given this time, so there's nothing to be squared and attached to this. Okay, once again, as I told you before, if you've got any questions, bring them to class tomorrow. I'll be glad to discuss them with you before we start any work. You just simply need to write them down if you're having trouble remembering them until you get to class, and then that way you'll have something to refresh your memory when you get there. Thank you very much. We'll see you tomorrow. Good night.